Absolute value functions and graphs. Go ahead and write down that definition. Vertex, a point where the function reaches a maximum or a minimum. So in this problem here, in this graph, my vertex is right here at the origin. So is your vertex, if I asked you if your vertex was a maximum or a minimum, in this case, what would it be? Minimum, because it's at the bottom of the graph. That's all you have to think of. If the graph were to open down, like this, the vertex would be at the top, therefore it's a maximum. So basically the vertex of an absolute value function is where your two sides come together. It will always form a V shape, absolute value. And that V shape is symmetrical. Everybody knows what symmetry is, right?
Yep.
Okay, symmetry is, if this were my, in this case, this is my line of symmetry, this axis is my line of symmetry. That means I could take this side and fold it along that line, and it would land directly on top of this side. Okay, and that's going to be important when I start explaining how to do the tables. Alright, so in this example, the first example, y equals absolute value of x is what we call the parent function. All other absolute value graphs are going to work off of this graph when we start talking about translations. Just moving it left, right, up, down. Alright, so for this one, you should be able, the more of these that we do, you should be able to look at it and tell what the vertex is. To get the x-coordinate of the vertex, you just look at the inside of the absolute value and figure out what is going to make this equal 0. What's going to make x equal 0? What does x have to be to make it equal 0? 0. So that's where I get this from. The y-coordinate of the vertex is what's being added or subtracted to the absolute value. Nothing's being added or subtracted in this case, right? So it is 0. So my vertex I always put in the middle of my table. And it is 0, 0, plot that point. Now, yes?
So you just said y equal to 0? It's an absolute value equation?
No.
Because don't you have to get...
No, I'm just trying to, for the vertex part?
Yeah, to figure out
For the vertex, I'm just trying to figure out what's going to make the absolute value equal 0, which would be 0.
So you have to
I'm not worried about y yet.
But
To get the y-coordinate of the vertex, what's being added or subtracted here? Nothing. So that's where I get 0 from.
Okay.
Alright, now when you do your other values, you can choose whatever you want. Now there are easy values to choose. In this case, these are the easiest values to choose. But again, you can choose whatever values you want for x. They don't have to be the same values that I choose. They don't have, your values don't have to be the same as his. As long as you pick two values, you need to pick at least two values to the right of the vertex and two values to the left so that you see that V shape on it. Okay? If you only picked one to the right or one to the left, it might end up looking like a parabola if you're not careful. Alright? Now notice the points I chose, 1, -1, 2, -2. This is showing symmetry right here. Okay? Since 1 and -1, those are corresponding values. They're both one unit from the vertex. That's what corresponding means. They're both the same distance from the vertex. Therefore, since an absolute value function is symmetrical, they must have the same y value. So once you figure out one of them, you don't have to go through all the work. I mean, there's not a lot of work in this one. But in other problems, there might be more work. But you don't have to go through all that work if you pick corresponding points. Alright, so if I figure out the absolute value of 1, what is it? 1. What's the absolute value of -1? It's also 1. 2 is 2. Absolute value of -2 is also 2. Alright, then all I'll do is plot those points. 0, 0, 1, 1, -1, 1, -2, 2, and 2, 2. And draw your graph. Okay? Alright, next one. here, y equals absolute value, 3x plus 12. And my table, now the one point that we do have to have in common is the vertex. Can everybody look at this and tell, based on what we explained in the first example, why the vertex is negative 4, 0? What's going to make, what does x have to be to make this equal 0?
It would have to be -4.
Negative 4. Question, or were you going to say that? Okay, that has to be negative 4. And again, if you can't look at it and tell, just take what's inside the absolute value and set it equal to 0. Take the 3x plus 12, set it equal to 0, and solve for x. Subtract 12, divide by 3, x will be negative 4. The y-coordinate of the vertex is what's being added or subtracted. Nothing's being added or subtracted, so it's 0. All right. Now, 2 points I chose, here's negative 4, 0. 2 points I chose directly to the right. I chose points directly to the right. Some of y'all might have chose 1 and 2 because you like 1 and 2, which is fine. Yeah, but it's going to make your graph bigger, so you're going to use a lot of paper. So I just picked the closest points possible. So I chose negative 3 and negative 2. So notice how I worked my table in the previous example and this example. This is how I always work my table, least to greatest. All right, so I chose negative 3 and negative 2, and what corresponds with negative 3 and negative 2?
3 and 6.
Negative 5. No. Which x values correspond with negative 3 and negative 2? What corresponds with negative 3? Negative 5. Because they're both 1 unit from the vertex. What corresponds with negative 2? Negative 6. Because they're both 2 units from the vertex. So all I do, and this is what I was showing over here. If you can't look at it and tell the x coordinate is negative 4, this is what we do. Okay. Then just plug in negative 3. What's negative 3 times 3?
-9.
Negative 9 plus 12. 3. What's the absolute value of 3? 3. So without doing the work for negative 5, I know this must be 3 as well because of symmetry. But if it makes you feel better, you can check the negative 5. What's negative 5 times 3? Negative 15 plus 12? Negative 3. And what's the absolute value of negative 3? Still 3. And negative 2 should give you negative 2 times 3 is negative 6 plus 12 is 6. Absolute value of 6 is 6. Therefore, this must be 6. Plot the points and draw your graph.
So you can set y as 0?
No, I'm not doing anything to y. I'm solving for y. I'm plugging in values for x and solving for y.
Yeah, I'm saying, so I'm looking on the example over there. Is it 3x plus 12 equals 0?
This is, no, this, I just took the inside of the absolute value and set it equal to 0.
Okay.
All right, to find the x coordinate of the vertex. That's what I'm doing right here. If you can't look at it and tell that it should be negative 4. Whatever makes the inside 0 is the x coordinate of the vertex. All right, now, on your calculator, let me show you this. Does everybody have the calculator out? All right, we're going to go to y equals. And we're going to do the example that I just did. Okay? Let me clear this and just start from scratch. All right. So if you were to graph this on your calculator, you would go to y equals, hit math, go over 1 to number, and it's the first one. ABS stands for absolute value. Now some of you, when you hit enter here, if you have the older version of the calculator, will get ABS parentheses on your calculator. I actually get the absolute value symbols because I get the newer version. Okay, so in the parentheses of your calculator, you'll just type in what's in the absolute value, which was 3x plus 12. So here's 3. Here's the x right here under the mode button. Everybody following me? Plus 12. And to get out of this, if you have parentheses, you need to close the parentheses right here. All right? I'm going to get out of it by hitting the arrow button over. All right? And then just before you, yeah, let's hit graph. And that's what it should come up to.
Can you answer?
Oh, wow.
Okay?
Holy
Keon?
smokes.
An error not showing principal, so.
Now, another thing you can do is get the table of values. So hit second window. And make sure, and you should get this to pop up. Second window. Now the only thing that you need to make sure of on your calculator that we'll need for the entire class this year, we want our independent variable on ask. I don't care what you have here, here, or here. Just make sure your independent variable is set to ask. So if it's not, if it's on auto, go down using the arrow button, move over to ask, and hit enter. So ask is highlighted. All right, that's going to allow me to plug in whatever I want for the x values. Okay. Then you hit to get your table. You hit second graph. And you may have numbers on there already, which is fine. You can type over the numbers since you're set to ask. If it makes you feel better, you can hit the delete button, and it will delete all your x values that you have in the table. And then just type in or type over the numbers you have. The same table that we just did in that problem. -6, -5, -4, -3, and -2. And you'll see that the y values just pop up for you. Okay, any questions about the calculator, how to use that? Yeah. Yes.
On like the ask thing,
Uh-huh.
we do independent or dependent on ask?
Independent.
The independent.
After I hit that, after I do this, how do I hit the other parentheses and the track?
I don't understand.
Okay. Hold on. All right. Yes.
How would you do the first thing?
The table setup.
Yeah, like when you moved over.
I went
and then
to
and then I got lost.
get the table set up. We go to second window, and you need to make sure the independent is on ask, and then from there you go to second graph to get to the actual table.
I mean, how did you get the graph part?
Just hit graph. Hit graph by itself, and the graph
The
pops up.
first thing that you taught us to do.
Go to y equals. You both have to go to y equals to type in the equation. All right. So you got it typed into just the home screen. You got to type it into y equals, and then you go to math 1.
And then see how you do this is 3x. Oh wait, no.